Today we will see another typical question for bearing design. Read the question. Load on a general bearing is 15,000 kg due to turbine shaft of 30 cm diameter running at 1800 rpm. Determine the following. Length of the bearing with allowable bearing pressure 16 kg per centimeter square. Amount of heat to be removed by the lubricant per minute. The bearing temperature is 60 degrees centigrade and viscosity of oil at 60 degrees centigrade is 20 centipoise and the bearing clearance is 0.025 centimeter. I hope the question is clear. The question with the various data are given. Load is mentioned, the shaft diameter is mentioned, shaft speed is mentioned, length of the bearing we have to calculate, and heat removed by the lubricant per minute you have to calculate, provided operating temperature is given. The viscosity at operating temperature 60 degrees is mentioned as 20 centipoise. Also the allowable bearing pressure also mentioned 16. So first part is a geometrical calculation or design calculation, length you have to fix. Second part, it is a direct equation calculation because I explained heat generated and heat dissipated several times. Using the standard equation or using from the data book, you just copy the equation, substitute and find out. But the B part, again carefully read the question. Amount of heat removed. So far we have explained heat generated and heat dissipated. But what's the meaning of heat removed? Yes, that is nothing but once you generate the heat, that much of amount of heat you have to remove. So it is indirectly you have to calculate heat generated. So whatever value you have calculated for heat generated, that is nothing but it is an answer for the question number B part, amount of heat removed. So first part length calculation, second part if you calculate heat generated, that is nothing but that much of amount heat to be removed during the operation. So first of all, every question what you have to do is to avoid confusion, all the data you have to dictate. I have already repeated the values 15,000, 1,830, 16 kg per centimeter square, 60 degrees centigrade, 20. What is this data? What are the parameters? First you have to dictate. Then you will get an idea how to proceed. So length of the bearing, already the length of the bearing. P is the allowed pressure. Allowed pressure given means the pressure is equal to load by area. Load is mentioned, area also mentioned, therefore nothing is confusion there. P directly you have to, P is also mentioned 16 and W is mentioned, area L into D. L is not mentioned, that you substitute like that. 16 is equal to 15,000 divided by 30 into L. Only one unknown is L, that way you have to reach the L. So L in this question 31.25, it is not important because you have to tally the SI unit tallying. So answer you are not sticking in this explanation. Either you have to convert the question itself to SI unit or you have to refer another typical same question converting the SI, or finally you can, whenever you are substituting, you have to calculate, you have to convert to SI. B part, I told you heat amount removed. Heat removed is nothing but heat generated. Heat generated equation is available in the data book. Before that, basic equation is, I told you, mu into W into V. Mu you have to calculate. W mentioned in the question. V is a peripheral speed, that is nothing but pi dn by 60. So first calculation is mu, coefficient of friction. For that you need viscosity, speed, allowed pressure, d by c, d and c values, k. This is the equation, but said this or known, n is known, p now calculated, d is known, c have to calculate for the it is given in this question, and k also mentioned in the data book. So directly whatever all the value known means, you now substitute in the mu equation, find out the coefficient of friction. Velocity pi dn by 60, pi into D known, N is known, that you can, without confusion you can calculate, and you will reach a value. Finally, Hg, heat generated, is equal to mu into W into V divided by mechanical equivalent of heat. That is for dimensional tallying. If it is SI unit, you have to check the equation, what is the unit left hand side and right hand side. Then only you have to decide whether J value is required or not, or the corresponding value of SI unit of J you have to substitute. That is your duty. So here, since this is an MKS unit, we are getting the value 655 kilocalorie per minute. If it is SI unit, you will get the value, some other value in the form of kilowatts per minute or watts per minute.